Let's look at how to determine the turning point of cubic functions. The turning points, normally we have two turning points for a cubic function. We'll have two turning points, the point of inflection, or just the point of inflection. But in most cases, we'll have. When you need to sketch the cubic function, I say you need to identify the shape by looking at it, okay, to tell whether it's going to be increasing, decreasing, and then now the turning points and the x and the y intercept. So now the turning points. Let's say we have something like this is your graph, and here's your turning point. You have two turning points. Now, if you draw a tangent at a turning point, remember a tangent is that line that touches the curve once. So when you draw the tangent at a turning point, it will be different from the tangent that is drawn this side, here and there. You will see that this tangent here is increasing, this tangent here is decreasing, this one here is increasing, but these two tangents here at a turning point, they are not increasing or decreasing, they are stationary. So it means the gradient here is 0. Now there's a relationship between the gradient of the tangent to a curve and its derivative. So if the function is given by this, ax cubed plus bx squared plus cx plus d, and you need to find the turning point for that function. Remember, the derivative of a function is equal to the gradient of the tangent to the curve at any given point. Now, at the turning point, the gradient is 0. We've just shown that the gradient is 0 at the turning point. So the gradient is equal to the derivative. Remember that. So we get the derivative. We say the gradient is equal to the derivative. So the gradient is 0. It means the derivative is 0 at the turning point. Now, what is the derivative of this? It will be 3ax squared plus 2bx plus c. That's the derivative is equal to 0. Now, the x coordinate of the turning point will be given by this equation here. You can see that this equation is quadratic, so you can factorize it, get the x coordinates of the turning point. Now, the y coordinate of the turning point is cheap. You take the x coordinate, substitute the original equation, that's your y coordinate. Now, let's take an example so that you can see what I'm talking about. Suppose you are to sketch this graph here. F at x is equal to, you are supposed to sketch f at x is equal to, I want to have something nice, something that is workable. X cubed plus 3x squared, minus 9x minus 2. Suppose you are being asked to sketch that graph. They say, given the function f at x equal to x cubed plus 3x squared minus 9x minus 2, sketch the graph. You are supposed to sketch the graph. Now, the first thing you see, this is cubic. You see it is increasing because 1 is positive. You see the coefficient of x cubed is 1, which is positive there. So you know your graph is increasing. Either you're going to have this shape or this shape. You're going to have this one or that one. So that one will come from our calculations. The first thing to get is the turning point. The turning point. The turning point. Alright. Let's try to get the turning point. We say the derivative of this is equal to the gradient of the tangents to the curve, and the gradient of the tangent to the curve at the turning point is 0. So we know that the derivative is equal to 0. That's what we know. Now the derivative is equal to 0. Let's differentiate this thing here. The derivative of this one is 3x squared. I hope you guys still know how to differentiate. And the derivative of this one is 6x. And the derivative of this one is negative 9. Derivative of a constant is 0. So this derivative is equal to 0. You can see this is a quadratic equation, a nice one. I think 3 goes into this and that and that. So let's divide by 3. We have x squared plus 6 plus 2x minus 3 which is 0. Now, we can factorize this. I hope you guys can factorize. Let's factorize this. Now, the factors you have x there, the factors of 3 is 3 and 3. The bigger one takes the sign of the middle term. It's a plus here. And then this one here is it's 3 and 1. Sorry about that. Alright, 3 and 1. So this one takes the sign of the middle term, this one takes, so you have your, we have factorized it nicely. So here we have x equal to negative 3 or x equal to 1. We have done that. So to get our y coordinate of the turning point, we substitute this x coordinate into our original equation there. So when we substitute x equal to negative 3 here, we'll get y. When we substitute x equal to negative 3 here, we'll get y equal to, remember this one will be negative 27 plus 27, negative 27 plus 27 is 0. And then we have 27 minus 2, which is 25. Do verify. But then we just put this 3 here, negative 3 here, we get negative 27. When we put the 3 here, negative 3, it will be positive 9 times 3, which is 27. Negative 27 and 27, you have your 0 there. You put your negative 3 here, times negative 9, it's your positive 27, minus 2 is 25. And then when you put your x equal to 1 here, x equal to 1. 1 cubed is 1. 1 squared, 1. Times 3, 3. Plus 1, 4. 4 minus 9, negative 5. Negative 5 minus 2, negative 7. So your turning point will be negative 3 and 25 and 1 and negative 7. So those are the coordinates of the turning point.